Alright, so one of my cousin asked that he is building a square column of 14 inches, but he does not know how many rebars or longitudinal bars should he place in the same column. Hey guys, I'm Suleiman Khan, and in this video we'll be learning how many rebars should be placed in a square column. And remember, I'll be using ACI, or you can say American Concrete Institute's codes, okay? And let me make some assumptions, okay, before doing the calculation. And as you can see, the size, that is just 14 times 14 inches, that is square, okay? And then we have the design load, which has already been factored, because that theta means it's already been factored, okay? And this may actually include the dead load, maybe the live load, okay? So this is actually the design load, which is 442 kip. Kip means one kip is actually 1000 pound, okay? So this is actually just a, you can say, unit of force or maybe unit of load. And then we have FC prime, which is 4 KSI. That is actually the strength of concrete, which is going to be used in the same column. FY, that is 60 KSI, or you can say the strength of the steel, okay? That is just the grade, okay? And then we have the requirements, which is actually the same thing as the design, or you can say the number of rebars, and this is our approach, okay? So without wasting time, let's just go ahead into the solution. And in the solution, make sure you are familiar with the design load, okay? This is the same formula which is already used, and this is just taken from a nice book that is just written by the Nelson, and the book's name, if I'm not wrong, and that is just actually the reinforced concrete design, okay? So this is a nice formula. As you can see, everything is just given, okay, without theta and alpha, and these things are actually 0.8, and for the theta, that is 0.65, okay? And these are actually the design capacities, okay? And these are actually for a square column. These can be just different for a spiral column, okay? So these are for high columns. And as you can see, in the same problem, we need the number of rebars, okay? For that, we actually need AST. Once we have AST, then we can actually calculate the number of rebars very easily, okay? So you can rearrange the same formula for AST. As you can see, the same thing, okay? And then what we have to do is just to do plug and check in the same formula. Like you can say AST, that is actually the design load, which is 442, you can say kip, and then we have the theta, which has already been known, 0.65, then the alpha times 0.85 FC prime, that is already known, 4 KSI, AG, that is actually the cross-sectional area of the column, which is 14 times 14, okay? And divided by the same thing, alpha and theta, okay, I mean theta and alpha, and then FY, which is actually 60, okay, KSI, that is grade of the steel, which is going to be used in the same column, okay? And then we have actually the same thing, 0.85 and FC prime, okay? Okay, so simple. And just do some maths. You can get actually AST 3.24 square inches. Once we have AST, then we can easily calculate actually the number of rebars. But make sure the number of rebars should not be less than 4, okay? That is actually based on ACI 318, okay, for a square column. Okay, so for a square column, the minimum number of bars are 4 and should be more, okay? You can say should not be less than 4, but can be 4 or maybe more than 4, okay? That is just the same thing, okay? And as you can see, we got this table. Here is a nice table, and I have taken the same table from the same book written by Nelson, okay? Reinforced concrete design. Okay, so this table is going to tell us how many number of bars and what should be the dia bar, okay? So as you can see, the area of steel, AST, that is 3.24. So I'm going to pick values near to that or equal to that. As you can see, I'm just picking 4 values. You can take more, okay? And should not be less than 3.24, because that's just the calculated value. Okay, now let's make our choices, okay? Like, let's just focus on 3.81. That is telling that we have to place 3 number of bars, and the dia should be 10 by 8 inches, okay? Or you can say number 10 bar. But I'm not going to take this because the number of bars are actually less than 4, okay? Those are 3, so I'm not going to take this because that is just the violation of ACI 318. And then as you can see, we have another option 3.95 that is telling that we have to put number of bars equals 5, but the diameter is going to be 1 inch, or you can say 8 by 8 inch. Okay, and then we have another option 3.6, that is telling that we should place 6 number of bars and the diameter should be actually 7 by 8 inches. But why I'm skipping these? Because in a square column it is really complicated and the pattern may not be that good with 5 number of bars and with 6 number of bars. However, if you look to the 3.52 area, that is telling that number of bars should be 8, but the diameter should be 6 by 8 inches, or you can say number 6 bar should be used. Okay, so that looks pretty good. Okay, and the pattern can be pretty good as well in the square column, so I'm going to take that one. Okay, that's pretty amazing. So number of bars should be 8 and the bar should be number 6, or you can say 6 by 8 inches must be the diameter. So I will say use 8 and number 6. Okay, and you can pattern that like the same thing is shown in the diagram. That's so simple. Okay, but one thing which should be checked is actually the percentage of steel, and that is actually according to ACI 318 that should be 1 to 8%. So let's just check the percentage of steel, and that should be actually AST divided by AG. AST that's already been just decided, which is 3.52, and divided by AG, which is actually 14 times 14 or 196 square inches. Okay, and that is actually 0.018, and that is actually 1.8%, which is actually more than 1% and less than 8%. So we are okay over here. Okay, according to ACI. So in the same video, in the same formula, in the same column, number of bars should be 8 and the diameter should be 6 by 8 inches. See you in the next video.